All right. Is this going to take more or less than 10 years?
More.
More or less than 20 years?
More.
More or less than 30 years? Less. All right. Let's talk our way through it. How did you begin to set it up? Yes, ma'am.
Okay, I'll set the right side up first. So I just put 1500 E, and then for the 4.3, I changed it to 0.043. And then the T.
Okay.
And then since it's triple, then it will be 1500 times 3, so it's just 45.
Love it. So what formula are you using there? Compound interest formula. Specifically the one for continuously. We got to use E, the natural number there. Yes. So A equals PE to the RT. Yep. Beautiful. Love the way it's set up. One more time, just for my own benefit, where did the 4,500 come from? Because it says to triple. So you do that initial amount, 1,500 times 3, and that's where we get that 4,500 from. All right, somebody else, tell me what to do after our setup. Pedro.
Which would be 0.043.
Okay.
Multiply that by. Oh wait, hold up. Oh, never mind. Wait, you divide both sides by 1,500.
There we go. Divide both sides by 1,500. And what do we get when we do that division? 3. So I want to pause here for just a second before we move on. Now that we see this part of it, I want you to tell me which piece of information in the original problem was unnecessary. The 1,500. Why?
Because as long as you know how much it goes up, then you don't really need to know.
Yes. We want it to double or triple or quadruple. It does not matter what the starting amount is, because when you divide both sides by that starting amount, you're going to get 2 for doubling, or 3 for tripling, or 4 for quadrupling. The initial amount is absolutely unnecessary information as long as you know what you want that investment to do. It's going to take the same amount of time for $100 to triple as it would $1,500, as it would $1 million. All you need to know about it is that it's going to triple. Keep that tucked in the back of your mind for the 5-6 homework. All right, now that we got it to here, though, what do I want to do? Can't divide by E.
Set it up for a natural log.
Set it up for a natural log. I can't divide by E because E has a power on it. So natural log of 3 is equal to, yep, 0.043t. And then after that, we're going to divide both sides by that decimal, 0.043. And if we take this out to 2 decimal places, we figure out that it is about how long? 25.55 years. Fantastic. All right, I want you guys to pull out the 5-6 notes. That was the front back that we started yesterday. We got almost all the way done with the front side. We still had 3 problems left on the front side to do. Yes, sir. Yes, I do. They're in the back. 5.6. No staples on these notes. It's just the front back one. We got all the way through problem number 6 yesterday. Yes, sir? Yes, we are going to take the quiz. When? A little bit. Huh? Okay. We're going to do some notes first. Your quiz is going to be a take-home quiz.
Thank you, Ms. Bolt.
You're very welcome. Tomorrow, when you come into the room, you will have up to 60 seconds after the bell rings to turn it in. Basically, do not come into the room tomorrow without it done and you're like furiously scribbling at your desk. It needs to be done when you come in, okay? If you're not going to be here tomorrow, if you already know in advance that you won't be here tomorrow, you can turn it in to me today. You can give it to a friend to turn it in to me. Or you can send it to me through Canvas. Just make sure that I get it before the start of 6th period tomorrow, which would be 12:48. Make sure I get it by then, okay? No exceptions on that. Normally we don't do take-home quizzes. I will pass it out to you at the end of class today. There is no homework due tonight. 5.5 homework was due last night. The 5.6 homework is due tomorrow night. I won't count it late until the end of the weekend, though. So if you don't get it done tomorrow night, if you work on it over the weekend, we're still good. Okay? All right. Let's go back to the notes. We were ready to start number 7. Where do you think I should begin this problem at?
Add 15.
Add 15 to both sides, okay. Once I add 15 to both sides, what should I do? I like the thoughts about natural log, but do I have just one exponential base? No. I have 2 bases. They happen to be the same base, but I've got 2 of them. In order for natural log to be useful here, I would need to get it to just 1 on one side. Divide by 2. I would have to divide everything by 2. So now I would have 1/2 e to the 2x equals plus e to the x equals 7.5.
Would you take out x's?
How? They're in my powers.
Can you combine them?
I can combine them if they're the same. Are my powers the same? So they're not like terms. Let's go.
Can you take out an e?
I like your thoughts. Unfortunately, we cannot. I want you guys to come back and look at this. What's next to that x? Anything next to that x? So the first one is like squared, right? E squared with an x. The other one is e to the first power with an x. Like a quadratic. This is a quadratic type problem. Do you guys remember when we learned how to do U substitution? I love the groaning. I love it. I live for this stuff. I'm going to let u equal e to the power of x. Anywhere I see e to the x, I'm going to replace it with a u. So that first term now becomes u squared. Plus what? 2u minus 15 equals 0. Can we factor that? Absolutely we can. How would that factor? U plus 5, and I'm sorry, I didn't hear the other one. U minus 3 equals 0. So what are the two values for u? Negative 5 and positive 3. Am I finished? No. Now I'm going to take that e to the x and substitute it back in the place of the u so that we can finish solving this. E to the x equals negative 5. And e to the x equals 3. Now what could I do? Now I can do a natural log. So the first one, e to the x equals negative 5, what would that one look like if I write it as a natural log? Natural log of negative 5 equals e. Or sorry, not equals e, equals x. What am I thinking? It wouldn't work because it's negative 5. Why does it not work because it's negative 5? Like, what is it about that that makes it?
The argument has to be positive.
Argument has to be positive. Any other part of a log that has to be positive? The base. Argument always has to be positive. Base always has to be positive. So this one is extraneous. The other one, could I write that one as a natural log? Yep. Natural log of 3 is equal to x. This would be my exact solution. I do also want to know an approximate solution for this. You said 1.099? 1.099 would be my approximate solution. Lovely. Nice work. Number 8. Where do I start this one at?
Add 5.
Add 5 to both sides. Four to the power of 2x plus 3 equals 14. What can I do with it from here? I can use logs. How could I use logs on this one?
Well, 4 would be the base.
4 would be the base. Okay, so I've got log base 4 of what? What would my argument be? 14 is equal to 2x plus 3. There's nothing wrong with what we just wrote, other than the fact that the calculators that I'm going to let you use on the test can't do log base 4. So if they can't do log base 4, how could I rewrite the left-hand side so that I could put it into the calculators that you're allowed to use? Change a base. What would this look like if I use change a base on the left-hand side?
Log 14 divided by log 4.
Yes, log 14 divided by log 4. Do you have to use common log for that? Nope. You could also choose what? Natural log. Basically, any of the logs that are on the calculator, you can change it to that base. We happen to have buttons for natural log and common log on almost every calculator. Question before we finish this. Just kind of a side note. Is this the same as what I just wrote over there?
No,
Why not?
It's not
because
this.
that's a fraction.
They're both fractions, right?
Well,
The one on the left
it
is
reduces.
log 3.5.
The one on the left is log of, what, 7 over 2, 3.5?
And the other one is just the log.
The other one is dividing 2
Logs.
logs. These are not equal. Do you guys know why the change of base is set up the way it is, why it works like that? All right. Again, before we finish this one, I do want to get into it. It is important, and it's going to help us on this next problem to fully understand what's going on here. So if I have something, say like x to the w equals y, how would I write that in its log form? All right, I'm going to focus on this, but keep this in the back of your mind over here, okay? Log is an operation. We can do it to things, just like you can multiply both sides by 5. You can subtract 10 from both sides. We can take a log of both sides. It's an operation that as long as I do it to one side, I do the same thing to the other side. So I can take a log of x to the power of w equals log of y. I can use a property of logs here. Do you guys remember our properties of logs? The quotient property, the product property, powers property.
You gotta put the W.
Bring the w to the front. And when it comes down to the front, it is now a coefficient. It's now being multiplied to that log. How would I get the w all by itself here? Divide both sides by log x. And so I would get w is equal to log y over log x. W is equal to log base x of y when I just rewrote it as a logarithm. When we solved it for w by taking a log of both sides, these two expressions are now equivalent. They have the same meaning. That's what's going on with my change of base. I can take a log of any base, just like I can multiply both sides by 7, or I can multiply both sides by 5. I could take a log base 10 of both sides, or a natural log of both sides, or a log base 32 of both sides, as long as it's the same log on both sides. Does that make sense? At least a little tiny bit? Okay. All right. We're going to come back and finish up number 8 now. What would I need to do as I continue getting x all by itself? Subtract 3 from both sides. So I'm going to have log of 14 divided by log of 4 minus 3 equals 2x. Divide both sides by 2, and I have to remember to divide everything on the left by 2. And then I can stick it in my calculator. We're going to get our approximate, we're going to get our approximate solution here. Negative 0.548. absolutely correct. All right, last one on this side. Number 9. Can I even do things to both sides right now? I can't add things to both sides. I can't multiply or divide things to both sides. Are my bases the same? Any other problem that we've had that looks like this, our bases are the same, or we can make them the same. Can I make these bases the same? No. 2 and 3 are both prime. Neither of them are powers of the other. So we're going to take a log of both sides. What kind of log should I potentially pick from? Like, what base log should I think about? What would make the most sense here?
6.
6? We could do log base 6. At the end of this, I'm probably going to want to put it in what? Probably going to want to put this in my calculator. Do I have log base 6 on my calculator? Common log or natural log. I probably want to pick one of those two. Technically, we can do a log of any base we want to. But keeping in mind that I'm wanting to put this in my calculator at the end, most likely, I'm going to pick from one of these two. I'm going to use natural log up here just honestly because I'm trying to write fewer letters, and it's less letters. So I'm going to do natural log of 2 to the power of x plus 7 equals the natural log of 3 to the power of 2x. Why was it helpful for me to take a log of both sides? What can I do now that I couldn't do before?
On the natural log of 3 to the power of 2x, you can move the 2 to the front.
Yes, I can move the 2x to the front using my power rule. I can also do that on the natural log of 2. I can take this entire exponent and move it to the front. Because x plus 7 is an expression with a plus or minus in it, pop parentheses around that. X natural log of 3, that right side. The 2 and the x are being multiplied, right? And the x and the natural log of 3 are also being multiplied. So this is one term on the right-hand side. On the left-hand side, I've got that plus inside those parentheses. What should I do over there? I'd really like to get rid of those parentheses. What's going on between the parentheses and the natural log? Multiplication. What property can I make use of here? Distribute. Let's distribute this natural log of 2 to both of these pieces here. So I'm going to have x natural log of 2 plus 7 natural log of 2 equals 2x natural log of 3. What's my goal in this problem again?
X.
Find x. Where is x? On both sides, everywhere. There's an x on the left and there's an x on the right. If I'm going to get x alone, do I want it on 2 separate sides? How can I get it to the same side? How could I get my x's to the same side?
Subtract.
Subtract. Let's subtract x natural log of 2 from both sides. Can that combine with the 2x natural log of 3? Nope. Not like terms because it's not the same log. So I'm going to have 7 natural log of 2 equals 2x natural log of 3 minus x natural log of 2. All right, I've got my x is on the same side, but it's in these two spots here. I can factor it out just the same way we would do this if it was 7 equals 2x minus x. How I could factor the x out there, I'm going to do the exact same thing here. So I'm going to have 7 natural log of 2 equals x. And then inside parentheses, 2 natural log of 3 minus natural log of 2. How can I get the x completely alone now? Divide by all that stuff that's inside parentheses there, so that I can get the x alone. So I'm going to divide by 2 natural log of 3 minus natural log of 2 on both sides. And while it is kind of gross and long, it will go into my calculator. And I can get an approximate solution from this. .226, yes. On your homework, it should tell you how many decimal places you need to round to. If it doesn't say, 2 decimal places is sufficient. Flip the page over. Yep. All right. How should I start number 1 here? Divide both sides by 3. I think you have the 5 notes out. And I think that's why you're confused. This is the one that I passed out yesterday that does not have a staple in it. Log base 2 of x equals 7. Put it in exponential form. So what would it look like as an exponential?
2 to the x equals 7.
Close. 2 to the 7th equals x. And now I can pop this in my calculator. X is what? What'd you say? 128. Number 2. Tell me what to do. Divide both sides by 5. So I get the natural log of x equals 7. Can't divide by natural log because it's not being multiplied. Remember, logs are their own operation. What undoes a log? What's the inverse? E. On a natural log, I want to write this as an exponential. So e to the power of 7 equals x. This would be my exact solution. Let's also get a decimal approximation. I'm sorry, one more time for me. 1096.63. Number 3. What do I do? 2x plus 10 is an argument. It's having a log done to it. What undoes logs? Exponents. So I need to rewrite this as an exponential so that I can isolate that argument. How do I rewrite this as an exponential?
3 squared
3 squared
equals 2x plus 10.
equals 2x plus 10. And then what? 9 equals 2x plus 10. Subtract 10 from both sides. And then divide both sides by 2. So x is negative 1/2.
No. Wait. Yeah, it's no. So you have to check, right?
We have to check. What am I checking for?
If it's positive, the argument is positive.
Check to make sure the argument is positive. So I'm going to take this and I'm going to substitute it back into the whole argument. So 2, and then I'm going to sub in that negative 1/2 plus 10. What's 2 times negative 1/2? Negative 1 plus 10. Is that positive?
Yes.
Yes. So is this okay as an answer? Yes. It's not x that can't be negative. It's the argument that can't be negative, or the base. But specifically, like, we're usually checking to make sure that the argument is not negative. Number 4. Where is x?
In the argument.
It's in the argument. How do I isolate an argument?
E of 5.
Yes. E to the power of 5. I'm going to rewrite this as an exponential. 2x plus 6. And then what? Subtract 6 from both sides. Be careful when you go to put this into the calculator. Most calculators, you're going to have to use an arrow key to tell it that you're done putting in the exponent. If you just do e to the 5th minus 6, it thinks you want to do e to the power of negative 1. Because it thinks that you want the 5 minus 6 up here. Use an arrow key when you're done with the exponent so that it knows I'm done with that part. Divide both sides by 2. So my exact solution is x equals e to the power of 5 minus 6 over 2. But the approximate solution would be what?
198 times 704.
I got the 71.206. Check your exponent thing. 71 point, I got 206. Are you able to get that, or do you want me to help you put it into your calculator?
Yeah, I'll put it around.
You got it okay now? Okay. Number 5. What can I do with this? How do I write this?
2 to the negative 1.
2 to the negative 1 equals 3x. What is 2 to the negative 1?
1/2.
1/2 is equal to 3x. Multiply both sides by 1/3. I love that you suggested multiplying by the reciprocal there. 1/2 divided by 3. I'm going to end up with this compound fraction. 1/6 is equal to x. Let's do number 6, and then I'll pass out your quizzes. What can I do here? Divide both sides by 2. So I get log base 4 of x equals 3/2. 4 to the power of 3/2 equals x. I like leaving this as a fraction because what do I know about fractional exponents? It's the same thing as, it's a root. Whatever my denominator is, that's my root. What's the denominator? 2. So what kind of a root? Square root. Square root of 4 to the third power. 2 to the third power equals x. So x is 8. Beautiful. All right, I'm going to pass out your quizzes. When are they due? Tomorrow. When tomorrow?
As soon as you get it.
As soon as you get in the